All right, we're moving on to Chapter 8. This is going to be Lesson 8-1, and it's going to be something called a geometric mean, so the geometric average, but we're going to say mean because we're big kids now. And we're going to start out by writing down the definition of it. So geometric mean. Let's underline that. All right. So the geometric mean between two numbers is the square root of their products. Okay, so that's as simple as it sounds. Um, so we'll do a little example here. The geometric mean. We'll call it x of the numbers a and b. So we're going to find the geometric mean, we'll call it x, of the numbers a and b. And it is x equals just what it says here. The geometric mean between two numbers is the square root of their products. So a times b. Okay, sometimes you'll see it like this. A over x equals x over b. Well, the way you solve that is you cross multiply and you get x squared equals a times b. And then to get rid of that x squared, you have to square root. So you're still going to get that x equals the square root of a and b. So just remember, if you have to find the geometric mean of two numbers, you multiply the two numbers together and square root them, and that's the geometric mean. We'll do a couple of quick examples. All right. So example. So a will have the number 12 and the number 3. And then we'll do b, another example. We'll have the number 8 and the number 4. All right, so find the geometric mean. So here we have x equals the square root of 12 times 3. So x equals the square root of 36. So simple, simple. X equals 6. That's the geometric mean. Now we'll come over here, find the geometric mean. Again, same idea. Square root of 8 times 4. So x equals the square root of 32. Well, 32 is not a perfect square, so we've got to come over here and break up 32 into 16 times 2, 4 times 4. And remember, when something shows up twice, you can stop. So x equals 4 square root 2. Remember, the little 2 is all by himself, so he's got to stay home. He can't go out. So x equals 4 square root of 2 is our geometric mean. All right, we're going to write down a theorem. We'll do 3 theorems, and they're all kind of wordy, but they're not very complicated. Okay, if an altitude is drawn to the hypotenuse, of a right triangle, then the two triangles formed are similar to the original and each other. So we're going to draw a quick example of what that looks like. I'm going to try to draw a nice right triangle, just like this. and we're going to call it triangle ABC. So angle B is going to be our right angle. Now remember what our theorem said is if an altitude is drawn to the hypotenuse of a right triangle. So that means it's going to be drawn to here. Well, remember, an altitude goes from vertex to the opposite side, and it goes perpendicular. So we're going to draw from our vertex to the opposite side, and it's going to be perpendicular. Then the two triangles formed are similar to the original and each other. So we're going to say this is triangle ABC, so this will be point D. And all this says is that I'm going to redraw these three triangles now. So our biggest triangle was triangle A, B, C, and it's going to be similar to our medium-sized triangle, which is triangle B, D, C, and that's going to be similar to our smallest triangle. These are all right triangles. So our smallest triangle is A, D, B. And so notice the way that I wrote them, I reoriented everything so that they're all facing the same way, they're all pointing the same way, all their corresponding sides are facing the same way, all their congruent angles are facing the same way, and so we can say that triangle ABC is similar to triangle BDC, and that's similar to triangle ADB. Remember, this is a similarity statement. Okay, we didn't do so well on this on the last test, so let's try to remember a similarity statement is not a sentence. It's this. That's a similarity statement. Alright, so as promised, we've got two more theorems. They're both very similar. First one's called the geometric mean theorem, and it's relating to altitudes. Okay, so it's not so important that you remember the names of all these theorems anymore because we're not doing proofs so much anymore. But it is important that you remember the theorem and the rules behind them. So the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of this altitude is the geometric mean between the lengths of the two segments. All right, so we'll draw a quick picture of that. Draw a right triangle. Right, so we have triangle A, B, C, and it says an altitude is drawn to the hypotenuse of a right triangle. So altitude to the hypotenuse. Separates the hypotenuse into two segments. So we're going to have segment X and segment Y. The length of this altitude, so the altitude is the red line, so that's this height, right? An altitude and a height is the same thing. So the length of this altitude, height, is the geometric mean between the lengths of the two segments. So the height of this triangle is equal to the square root of x times y, because this is the geometric mean. So we want to memorize this. Okay, we're going to do one more theorem, very similar. So this is the geometric mean theorem for a leg. Remember, this last one was for an altitude. Okay, so we're going to skip the first sentence which says the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. Okay, so if you want, you can go back up and say this sentence goes down here. So you don't have to write it all again. And we're just going to write after that the length of a leg is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. All right, so another quick picture. Right triangle. I'm intentionally drawing all these right triangles not the way we're used to drawing right triangles, because I want you to get used to seeing right triangles in different orientations than just always like this, because they don't always look like that. So that's why we're drawing them differently. All right, so here's our right triangle. Here is our altitude drawn to the hypotenuse. Okay, so it says the length of a leg, so that's these legs here, the legs of the right triangle. Right? There's legs and a hypotenuse, so this is A and B. So the lengths of the legs is the geometric mean between the length of the hypotenuse, so that means we have this hypotenuse, well that's going to be C, right, A, B, and C, and the segment of the hypotenuse adjacent to that leg. So this little segment will be X, and this little segment will be Y. So what we're saying here is that A is equal to the geometric mean of X and C. So it's the geometric mean of X times C. And B is equal to the geometric mean of Y times C. Okay, it's not real hard. The math is very easy. So we're going to do a quick example. I'm going to draw this one a different way. This is the way we're used to looking at them now. So here's our fantastic right triangle. We're going to draw a altitude. And we're going to go ahead and label this thing. So this will be Y, Z, X. And our lengths right here will be 2 and 5. So we're going to find X, Y, and Z. So first we'll start with X. Well, X is the altitude, and the altitude is the geometric mean of the two sides that it splits. So it's the geometric mean of 2 and 5. So it's the square root of 10, which we don't know, so that's our answer. I'll move on to Y. Y is one of the legs. So the leg is the geometric mean of the hypotenuse and the segment that's adjacent to it. So the hypotenuse is 7. The segment adjacent to Y is 2. So Y equals the square root of 14, which we also don't know, so we're done. And then we move on to Z, which is the square root of the hypotenuse and the leg adjacent to it. So Z equals the square root of 35, which again we don't know and we can't figure out, so that's it. All right, so that's geometric mean. See you tomorrow.